Assalamualaikum and a very good day. My name is Muhammad Ariff Iskandar, a student for mechanical engineering in UTP, currently studying fluid mechanics, and this is a lab presentation on fluid statics under the topic that I have chose, which is Archimedes' principle. So, to start, first we need to understand what is Archimedes' principle. So, this theory states that the upwards buoyant force exerted on a body, whether fully or partially submerged in a certain fluid, is equal to the weight of the displaced fluid. And this theory is denoted as the following equation, as can be seen in my slides. Fb equals to rho Vg. So moving on with the objective, we do this experiment because we want to verify Archimedes' principle, and then we want to understand how the weight of the displaced fluid relates to the exerted buoyant force, as we have stated just now under the Archimedes' principle. So moving on with methodology, I've prepared here a figure of how the apparatus will be set up for us to run this experiment. So to start the procedure, we start by placing a beaker on a triple beam scale that is tiered or zero the scale for easier data collection. And the function of this setup is to collect the overflow water from the Eureka can. So the Eureka can was filled with water up to the overflow hole without actually having water overflowing from it. We just want it to be just nice on the overflow hole. So next we have some type of load, a mass, which in my case I've chose a cylindrical load with a weight of 0.3 Newton that is placed on a spring balance with a thread above the Eureka can. So as the experiment progress, we slowly and carefully suspend the weight of 0.3 Newton weight into the water in the Eureka can until it is fully submerged in the water without actually touching the bottom of the Eureka can. So what will happen is that the reading on the spring balance will change, and also we will have the overflow water into the beaker that we have set up just now. So what was on the spring balance is called the apparent weight, and the weight before we put the mass into the water is called the actual weight. And then we will also have the water in the beaker, which is called the weight of displaced fluid, and all of this is recorded. So this experiment will be repeated with a 0.3 Newton weight increment. Moving on, for the results, as you can see on my table here, it shows a very consistent results between the weight displaced and the exerted buoyant force. As you can see, I've chosen to repeat this experiment a number of 5 times for consistency purposes. And you can see that the relationship between the weight displaced, the weight of fluid displaced, and the exerted buoyant force is always consistent in each and every experiment that I ran. So, for the discussion part, how did we get the buoyant force from the weight of fluid displaced is by calculating with the following equation, which is subtracting the apparent weight that we recorded just now from the actual weight as denoted in the following equation, Fb equals to W1 minus W2. So, to conclude my experiment, as we can see with the result just now, we can see that the relationship between the weight displaced and the exerted buoyant force is exactly as how the Archimedes principle theory told us so. So all in all, what we can say is the Archimedes principle is verified, and we have obtained what we wanted throughout this experiment. And that is all from me. Thank you.